right. So we're going to start with 8.2, 0 and negative exponents. So don't think too hard about it yet. Okay, what that means. Okay, because I am gonna go over something. It's kind of conceptually that hopefully will help you understand this. But let's kind of review the exponent rules together. Okay.
Okay.
So, and I don't care about the titles of these things because everything starts with a P. That's all I know. So, a to the m times a to the m. When I'm multiplying two powers that are the same base and raised to an exponent, what's the result going to be?
Adding the exponents.
Yes. All right. And if I take a power, a base raised to a power, and I raise it to another power, that means whatever is happening in here is getting multiplied to itself n times. So a to the m gets multiplied to itself n times. Then what happens here?
You multiply the powers.
You multiply the powers. Okay. And then this was the other one, right? If I have two factors, they're being multiplied together, and I raise that to a power, what do I get?
A and b m, so you
A to the m,
distribute it?
b to the m. Yeah, I don't want to call that distributive because it gets confusing here because this is really multiplication going on in here. So just think about this. Whatever's happening in the parentheses, this is getting multiplied to itself this number of times. So it's AB times AB times AB m times. And that's why you end up with A to the m times B to the m. A gets multiplied to itself m times, and B gets multiplied to itself m times. So you end up with that. Now, the other thing I want to do is I want to, the book introduces this property just a little bit later, but I think it's helpful to know it now in explaining the whole zero but it's kind of related to this. How about this? If I have, let's say 2 cubed, and I divide it by 2 squared. So this is going to be the division property here in a second. Well, what does this really equal? 2 to the third is really what? 2 times 2 times 2, which is what? 8. And this is 2 squared, which is really
4.
2 times 2, which is 4. And this really equals 8 divided by 4 is really 2. What power is this?
1.
The first power. So what happened here between, if I want to skip this middle part and just do something with the powers and the base, what did I do to get to this? This was to the third power, that's to the second power, now I ended up with something to the first power. So what happened?
You
Subtracted. Okay? So this is the property that goes with that, and they're going to really go into this a lot more later. But if I have two things that are the same base that are being divided, the exponents end up being subtracted. I subtract the exponents. Just like when I'm multiplying them, I add the exponents. When I'm dividing, I subtract the exponents. Okay? And you can think about this. I have about 3 cubed divided by 3. Okay? What power is this 3 right now? If it's not written, it's a little invisible 1, right? So this is really the same thing as 27 over 3, and I know that's equal to 9, but what is 9? 3 squared. So 3 minus 1 gives me 2. Okay? All right, so you got that. All right, now, I think this section is easier to understand once you understand how that works. Okay, so let's do this a little bit more. Let's start with 2 to the first power. What is 2 to the first power really? 2, right? And then 2 to the second power. What is that? 4. And 2 to the third power is 8. And 2 to the fourth power is 16. And 2 to the fifth power is 32. I just keep multiplying the top one by 2 over and over, right? So, okay, all right, then let's step back. And if I say, I'm going to divide everything by 2 to the first power, Okay?
Mhm.
So 2 to the 5th divided by 2 to the 1st, right? I subtract the exponents, what do I get? 2 to the 4th, right?
Oh,
So, which is true. 32 divided by 2 is 16,
Mhm.
right? All right, let's just do it again. 2 to the 1st. Okay, so I get 2 to the 4th. That's really 16 divided by 2, which is 8, right?
Mhm.
So that's 2 to the 3rd, right? 4 minus 1, there it is, right? All right, so here's 8. Now I'm going to divide that by 2. And I keep stepping down, right? I get 2 to the 3rd, that's 8, divided by 2, well, I know that's 4, okay, which is this. 3 minus 1 is 2.
Mhm.
All right, well, here's 4. Now I'm going to divide that by 2. I know 4 divided by 2 is 2, and 2 minus 1 is 2 to the 1st power, all right? Okay, now I got 2 here, and I'm going to divide it by 2. Well, what is 2, anything divided by itself, what does that equal to?
1, but the
1, that's 1, but what's my exponent here?
0.
0.
Oh.
So anything that is not 0, doesn't equal 0, anything to the 0 power equals 1. 8 to the 0. 8 to the 0 equals 1. And how did I get here? I got it by having 2 powers that are exactly the same divide into each other.
Mhm.
And I get this to the 0 power, which is always 1. Doesn't matter what it is. It's 5 billion to the 0 power, 1. And you'll see, like on some tests and stuff like that, they'll try to get you like all, like they'll say x squared plus bx plus c plus 5,000 to the 0 power. Guess what? That's equal to 1. Okay. So anything to the 0 power is always 1. Doesn't matter what this base is. Okay. And that's where this comes from. Okay, it comes from doing this. But let's keep going. All right. And what happens when I take the number 1 and I divide it by 2? What happens when I take 1 and I divide it by 2? What number do you end up with? 2. If I take 1 and I divide it into 2, if I take 1 cookie and I divide it into 2, how much cookie are you going to get? 1 half. Okay, so if I take this is really 1, and I'm dividing it by 2, what happens to my power here? What's 0 minus 1?
1. Wait. Yeah.
What's 0 minus 1 equal to?
Negative 1.
Negative 1. That's what this is. Okay, so when you're talking about a negative exponent now, you're talking about a fraction. You're talking about its reciprocal. Okay? All right, so 2 to the negative 1 is the same thing as 1 half. Okay, well think about now if I have 1 half and I cut that in half. What's a half of a half? 1/4. So if I take this and I divide it here, then I'm going to get negative 1 minus 1. What does that equal?
Negative 2.
Negative 2. So this becomes 2 to the negative 2. Okay? All right, you see that? Okay, good. Okay, now, I think it's easier now to understand this section, understanding how division works, okay? All right, so take a look on page 449. And, they give you another explanation here, too. They say, okay, it says, by definition, a to 0 is determined by the product of powers property. A to the 0 times a to the n equals a to the, you add it up, right? 0 plus n, which equals a to the n. So by that definition, this equals 1, right? Because if I take this and I end up with a to the n at the end, then this must equal 1. And there's another explanation for why that works. Okay, now, here's the other thing they say. If I have a to the n times a to the negative n, well, then I'm going to add this up, right? I get a to the n plus a negative n, which is the same thing as a to the 0. Okay, and that equals 1. And so because of that, they're saying those are And those are multiplicative inverses. Remember the multiplicative inverse property?
Mhm.
So that A times 1 over A equals 1.
Mhm.
Well, that's kind of another way of saying that, the
Okay.
multiplicative inverse property. All right, so by definition, or by proof here, A to the 0 is 1, and A to the negative n equals 1 over A to the n, and of course they make a little caveat here, A cannot equal 0. Why can't A equal 0?
Because A is a 1.
No. If A was 0, what's 0 to any power? It's going to be 0 times 0 is
0.
0. I end up with 1 over 0, and
Oh, and then you get
it's undefined. So that's why they have to restrict that, and they say no. This property works as long as A is not equal to 0 ever.
Mhm.
Okay. All right. So is this sort of making
Yeah.
sense? It's like a new thing, but
Yeah.
it kind of holds together and makes sense.
Mhm.
All right. So let's take a look at example 1. And here, I think I got all my properties right over here. So I'm going to erase this if that's okay.
Yeah.
All right, so let's look at example 1. Example 1 says 5 to the 0 power. What does 5 to the 0 power equal to then?
1.
1. Okay. Oh, this is the other thing. 0 to the 0 power is undefined. That's undefined. Why is that? Because I would have to do this to get 0 to the 0 power.
Oh.
So 0 to the 0 power. If you put it in your calculator, 0, little caret, 0,
Mhm.
it will give you an error. Okay? All right, how about this? Negative 2 to the 0 power equals,
Negative 2.
and remember, anything to the 0 power is.
Oh, 1.
So that's 1. All right, and then 1/9 to the 0 power.
1.
1. Okay. So you know everything to the 0 power, no matter what, is 1 except for 0, which ends up being undefined. Okay. All right. Now let's flip over to example 2. All right. 2 to the negative 2 power. Okay. What you want to do is you're going to write it as its reciprocal, and the exponent then you see becomes positive. Once it goes over the bar, and it becomes positive. So what is this the same as?
1/4.
1 over 2 squared, right, which is 1/4. Yes. All right, and then, now, the other thing, and they didn't put this in the blue box, but it's true. If for some reason I have this written down like this, you see it's kind of written as in fraction form, but it's got a negative exponent here.
Mhm.
This is the same, this is the reciprocal, and it goes up, and then sign changes to positive.
Oh, okay.
Okay, and so I'll show you for a second with that. So let's look at this. This is 1 over negative 3 to the negative 4th power. Okay, so anytime the exponent is negative, depending on where it is, you can push this number up. In other words, you're getting the reciprocal of the number,
Mhm.
and when it does that, then the sign changes. So
Be 3 to the 4th.
it's 3 to the 4th. And actually, this negative goes away because this is still even, okay? So it's 3 to the 4th. And 3 to the 4th is really the same thing as 3 times 3 times 3 times 9 times 9, which is,
81.
okay? All right, so the other thing that you can do with these is you can do them in your calculator too, and you can double check.
Oh.
So if I had something like 1/3 to the -2 power, well, what is that? This means that it's going up
Mhm.
and it's squared, right? And that's 9. But put it in your calculator. Put 1 divided by parentheses -3 little caret 2, or hit the x squared button, and you should end up with 9.
Okay, so 1 divided by
1 divided by parentheses, so 1 divided by parentheses, 1 divided by 3, parentheses, 3 caret -2. And you know what I'm talking about when I'm
Yeah.
talking about caret.
9.
9. Okay, so that's how you can double check these to make sure that you're thinking about it the right way. Because this thing with the negative exponents and stuff like that, it's going to take a little while for you to build some intuition about what that means.
Yeah.
But anyway, so why don't you do this? Why don't you do the checkpoint and then you can take your break.
Okay.